For the AFOQT physical science subtest, we're diving into heat and thermodynamics. You will definitely see questions on temperature scales, so let's start there. The exam expects you to know Fahrenheit, Celsius, and Kelvin. While you should remember water freezes at 32 Fahrenheit and boils at 212, the most critical conversion for the AFOQT is between Celsius and Kelvin. The formula is simple. Kelvin equals Celsius plus 273. An exam question might ask you to convert 27 degrees Celsius to Kelvin. You just add 273 to get 300 Kelvin. The common trap is a multi-step problem, perhaps giving you a value in Fahrenheit and asking for the Kelvin equivalent, forcing you to convert to Celsius first. Remember, the Kelvin scale is built directly off Celsius, not Fahrenheit. Next, let's tackle heat energy itself using the specific heat formula, which is Q equals mcΔT. In this equation, Q is the heat added, m is the mass of the substance, C is the specific heat capacity, and delta T is the change in temperature. A typical AFOQT question won't just ask you to plug in numbers. Instead, it will likely ask you to solve for the specific heat capacity, C. For example, if adding 200 joules of heat to 4 kilograms of a liquid raises its temperature by 10 degrees Celsius, you'd rearrange the formula to C equals Q divided by the product of m and delta T, which would be 200 divided by 4 times 10, giving you a specific heat of 5. The biggest trap here is units. They might give you the mass in grams, and you must convert it to kilograms before calculating. Understanding how heat moves is also essential. There are 3 modes of heat transfer: conduction, convection, and radiation. A simple mnemonic to keep them straight is to think of a campfire. Conduction is the direct transfer of heat through contact, like burning yourself by touching a hot metal poker that was in the fire. Convection is heat transfer through the movement of fluids, like the hot air and smoke rising from the fire. You'll see this concept applied to weather systems or boiling water on the exam. Radiation is heat transfer through electromagnetic waves, which needs no medium. This is why you can feel the warmth of the campfire on your face from a distance, even when you're not in the path of the rising hot air. The exam will try to confuse radiation and convection in scenarios like this. Finally, we need to cover phase changes. This is a favorite AFOQT topic. When a substance changes phase, like ice melting into water or water boiling into steam, its temperature remains constant during the entire process. All the heat energy being added is used to break the bonds between molecules, not to raise the temperature. An exam question might show a heating curve graph with a flat plateau and ask what is occurring. The answer is a phase change. The trick is to not assume that adding heat always means a temperature increase. During melting, freezing, or boiling, the temperature is fixed. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.